So this lesson is taking quadratic equations and showing the relationship between factoring and solving it and what that does for the graph. So we're going to actually graph some of these quadratic equations. So this is your general form for a quadratic function. For it to be quadratic, it absolutely must have an x squared. If it didn't have this piece, then this is really y equals mx plus b. It's really linear. So it has to have that x squared to be quadratic. So that's what you're going to look for. Every time you see an x squared, you know it's going to be quadratic. Now, let's talk about some vocabulary. 4 words that mean the same thing. Solutions. Solutions are when you set that quadratic function equal to 0 and you solve it, and you get the solutions. The solutions are the same thing as the x-intercepts. Now the x-intercepts are on a graph where it crosses the x-axis. So my solutions are these places where it crosses the x-axis. So that helps us graph it. Now 2 other words that you're going to see thrown around here that they expect you to know are roots and zeros. Now these roots are not like the square roots that we've done before. These are just roots, not square roots or cube roots, just roots. Roots also mean solutions. And then zeros also mean solutions. And technically they're called zeros because when you get a solution, you're setting the function equal to 0 and you're solving it. So all 4 of these words you need to be able to know are completely interchangeable. If I say, find me the zeros, you need to know that that means I need to solve it. If I say, find me the x-intercepts, you need to know that means you need to solve it. If I say, find me his roots, you need to know that means you need to solve it. Okay? So state whether it opens up or down the x-intercepts, the y-intercept, and the graph. Well, the whole up or down thing, the graph of a quadratic function looks like this, kind of a U. Now, it can also look like this. And that all has to do with that number right there sitting on that x squared. If he is positive, we open up. If he's negative, we open down. So, and looking at number 1, first of all, yes, he is quadratic because he has an x squared. And this function is going to open up because the x squared term is positive. I don't care about any of the other terms, but if the x squared term is positive, then he's going to open up. Okay, so now I need to find the x-intercepts. Well, you'll remember x-intercepts are the solutions. So what I'm going to do is I'm going to take x squared minus 4 and I'm going to set it equal to 0. And I'm going to solve it. Well, to solve something that looks like this, you're going to factor it. That's why we spent all that time working on factoring. Well, to factor it, you know you have 3 options. You have GCF, you have squares, and you have a trinomial. Well, these are squares. So these factor x and x, 2 and 2, 1 plus 1 minus. But it still equals 0. Once you have factored it, you take each of his factors and individually set them equal to 0 and solve each one. So his solutions are x equals negative 2 and x equals 2. Well, if those are his solutions, those are also his x-intercepts. Now the y-intercept is really interesting and super easy. The y-intercept is always that constant guy on the end. Whatever he is, that's where we cross the y-axis. So ours is -4. So our y-intercept is a -4. So I know that it opens up. I have found my x-intercepts here and here. And I know my y-intercept is a -4 because that was my constant. So let's go put some dots on our graph. I got x-intercepts, that's on my x-axis, at 2 and -2. I have a y-intercept at -4. And I know it opens up. Ta-da! There it is. And we've got lots of these to practice, okay? So here we go, number 2. State whether it opens up or down. State the zeros. Okay, now they've changed vocabulary here. The zeros, these zeros are the same things as x-intercepts and solutions. Set vocabulary. The y-intercept and graph. Okay, well, first of all, yes, he is quadratic because he's got an x squared. I know that he opens up. How do I know that? Because his x squared is positive. To find his zeros, I'm going to set him equal to 0, and I'm going to solve him. So I'm going to factor that. That is a trinomial. Factors of 6 that subtract to give me 5 are 1 and 6. Signs are different. Bigger numbers negative. Set both of these individually equal to 0. Those are his zeros, his solutions, but on a graph, they are his x-intercepts. To find my y-intercept, remember that one's super easy, that's just your last number, the constant. So his y-intercept is a -6. So let's put some information on my graph. All right, I got an x-intercept at -1. Boom. I got an x-intercept at 6. I got a y-intercept at -6. And I know that he opens up. Okay, here's what I don't want to see. That's not a parabola. Parabolas are symmetrical. So just because this is the y-intercept does not mean that this is the vertex. So let's try this again. So we have an x-intercept at -1, 1 at 6, and 1 at -6. So here's the deal. Parabola comes down, hits the y-intercept, bottoms out, comes back up. See, my vertex is somewhere down here. This is just a y-intercept. But you've got to remember that your parabola is symmetrical. But he's got x-intercepts at -1 and 6. He's got a y-intercept at -6, and he opens up. Okay, yes, this is a parabola. It's got an x squared. And I know it opens up because that's 2 and that's positive. I'm going to go ahead and do my y-intercept because that's really easy. My y-intercept is a positive 2. To find my solutions, which are my x-intercepts, I'm going to take this guy and I'm going to set him equal to 0. I'm going to solve him. Okay, so what kind of factoring is this? Well, it's not a trinomial because it's not cute. You've got a GCF first. Remember, every time you factor, you always try to GCF first. So I'm going to pull a 2 out. So x squared minus 2x plus 1 equals 0. Now I've got a trinomial. Okay? Now I'm going to take all my parts and set them equal to 0. 2 equals 0 doesn't make sense. There's no x in here, so he doesn't count. X equals 1 and x equals 1. Okay, that's the same number. So that means he crosses the x-axis at 1. His y-intercept was a positive 2. And he opens up. Okay, if I come down here and come down through it, aren't I going to come back up? And I can't come back up because my only x-intercept was a 2. Or, sorry, was a 1. So, when this happens, when you get the same answer twice, it's called a double root. And when you get a double root, your parabola does not go through it. Excuse me. It bounces on it and comes back up. So it's going to come down, hit that point, and bounce back up. And that way, that's the only place, excuse me, that it crosses the x-axis. Okay? I know this is a parabola because it has an x squared, but look right here. This opens down. So this one's going to open down. Let's go ahead and do my y-intercept because that's really easy. That's my constant, which is a 6. To find my, now they're calling them roots, but we know that that just means solutions or the x-intercepts. I'm going to take negative 3x squared plus 3x plus 6, set it equal to 0. Definitely has a GCF. Okay, but here's the deal. When you have a negative in the front, you have to take the negative out. So I'm going to GCF a negative, and I'm also going to take out a 3 because they all have a 3. So if I divide everybody by a negative 3, what's going to happen to all my signs? Well, let's see. These cancel. That gives me x squared. If I clean that up, that's going to give me a minus x, and that's going to give me a minus 2. So if you GCF a negative out, it ends up changing the signs inside your parentheses. Trinomial. Factors of 2 that subtract to give me a 1 are 2 and 1. Signs are different. Bigger numbers negative. Set all the parts equal to 0. This doesn't make sense because there are no x's in there, so we ignore him. Those are my two solutions, so those are my two x-intercepts. So 2 and negative 1. And my y-intercept was 6. Okay, and remember he opens down, so this should make sense. But is this y-intercept my vertex? No, he's not in the middle of these 2 points. So what happens is it comes up, goes a little bit farther, and then comes back down. Because remember, it's got to be symmetrical. So the kicker on this problem is when you have a negative in the front, you take that out with your GCF. Just remember, when you put this under here, it's going to change those signs. Okay, yes, he is quadratic. He opens up because my 5 is positive. My y-intercept is a negative 5 because of that guy. Set him equal to 0. And let's factor him. I can GCF, oh, sorry, that's not a negative 5. I can GCF a 5. Gives me x squared minus 1 then those are squares. Then set all my parts equal to 0. He doesn't count because he has no x's. So I have an x-intercept at 1 and an x-intercept at -1. I have a y-intercept at -5. Okay, so here's a question for you. Is this y-intercept also the vertex? Yes, because it's in between, exactly in between the other 2 points. Oh, that's the worst parabola ever. There we go. There we go. Kind of looks like a reindeer. Okay, so opens up, has x-intercepts at 1 and -1 and a y-intercept at -5. It's all symmetrical. All is good. Okay, so here we go. I know it's a parabola because it has an x squared. This guy opens down, and my y-intercept is a -5. Then I take all this mess, set it equal to 0. Okay, I'm going to GCF a 5, but because the leading one's a negative, I'm going to GCF a -5. So if I divide everybody by -5, that would give me x squared plus 2x plus 1. Then I'm going to go right into a trinomial. Factors of 1 that add to give me 2 are 1 and 1. Sign the same, both positive. Then I take all my parts and I set them equal to 0. He doesn't count because he has no x's. Okay, these are the same. What was that called again? That's called a double root. What does that mean? I only have one spot here where this graph touches the x-axis. That means we bounce on it. Okay, I've got a y-intercept of -5. But remember, you open down. So if I open down, come up, bounce, come back down. When you have a double root, it doesn't go through it. It bounces on it. So this is how it might look on a test. Without a graph, it's just going to say, what are the roots of that function? Well, roots means solutions. Remember those 4 words that all mean the same thing? Roots, zeros, x-intercepts, and solutions. So it just wants me to solve it. So I'm going to factor this. These are squares. 4x and 4x and 7 and 7 and 1 plus and 1 minus. Okay, so I know it's going to be either C, that's supposed to be a D, or D. A lot of people jump the gun here on what they pick. Take the time and set it equal to 0 and solve it. Again, a lot of people when they get to a multiple choice question will just start guessing instead of working the problem all the way out. That's a -7/4. And that's a +7/4. So we're going to go with 4/7 and -4/7, or 7/4 and -7/4. Going with D. Okay, now this is them just being a pain in the butt. What is the sum of the zeros? And zeros are the same thing as solutions. Okay, but when I get my solutions, what does sum mean? Sum means add. So once I get my solutions, I want to add them. Okay, so let's take this guy to find his solutions. I'm going to set him equal to 0. And I'm going to factor factors of 8 that add to 6 are 2 and 4. Sign same, both a negative. All right, but you haven't solved anything yet. You've just factored it. So those are my two solutions. But it wants the sum of them. So it wants me to take my two solutions and add them together. So 6 is the answer. Okay, what are the roots of the equation? Okay, so what's different about this one? It's not set equal to 0. You can't factor or solve a quadratic equation until it is equal to 0. So the first thing you need to do is move that 6. Do not try to factor this. The first thing you need to do is subtract 6 over to the other side. So that's going to give you x squared minus 3x minus 18 equals 0. Now we're equals 0. Now I can factor this as a cute little trinomial. Factors of 18 that subtract to give me 3 are 6 and 3. Signs are different. Bigger numbers negative. Then set them both equal to 0 and solve them. I got a positive 6 and a negative 3. Okay, so let's see what these look like multiple choice with graphs. Now this one freaks me out because this one has a fraction in front. What the heck? But look, if you just piece together what you know about these, you'll have enough information to pick your answer. I know he's quadratic. Well, these are all parabolas, so we're good there. I know he opens down because that's a negative in the front. Well, guys, there's only one that opens down. Answer's got to be D. Now, if you had two that open down, the other thing you know without doing anything is that your y-intercept is a 6. So he has to cross the y-axis at 6. So again, use the information that you know in order to pick your answer. Okay, what is the graph of this function? Okay, well I know he's a parabola and I know he opens up. Well, they all open up, so that doesn't help me at all. But what else do you know? Well, I know his y-intercept should be a 7. Well, that's not a 7. That's not a 7. There's 7, and he's not at that. There's 7. And he's crossing right through it. Bingo. Okay, now this one. A lot of people look at this one like, oh, I need to FOIL it. I need to distribute. I need to lobster. But guys, they have already factored it for you. Now all you have to do is take each factor and set it equal to 0 and solve it, because then you will know what his x-intercepts are. So I know he should cross at a -5 and a +3. Well, here he is. He didn't cross at all. Now he crosses at a -3 and a +5. Okay, now hold on a second. This one is really tempting because look, +5, +5, -3, -3. But this is not the right answer because you have to take these over here, set them equal to 0, and solve them to figure out where it crosses. This guy crosses, I don't know, -1 and 4, so no. He crosses, here he is, -5, +3. Bingo. Okay, so what about this one? This one's been all kinds of factored. So first of all, I know he opens down. So B is out. Okay, he's already been factored. So I'm going to take all his parts and set them equal to 0 and solve them. He doesn't count. I'm looking for a -2 and a -6. -2, 3, 4, 5, 6. -6. Bingo. And again, here's the one that's at a +2 and a +6. But you do not get your x-intercepts from looking there. You have to set them equal to 0 and solve them. Okay, number 14, which is the graph. Okay, well, I'm looking at the front. That's a negative, so I know he opens down. So A is out, D is out. If I take these two factors, which they have already factored for me, and set them both equal to 0, and solve them, I get a negative 3, but I only get 1. So that means I know at negative 3, it should bounce. This one's going to go through a negative 3 and a positive 3. I don't want that. So make sure you know, for it to be quadratic, it must have an x squared. This is the guy that tells you if you open up or down. That is your y-intercept. To find your x-intercepts, you set it equal to 0, you factor it, and then you solve each factor. And that's where it crosses the x-axis.